Maintenance has always been a problem to airlines. All modern passenger airliners are complicated pieces of equipment. And our DC-10 is no exception. There are around 120 systems in this aircraft, and frankly, once in a while, we have to do some troubleshooting. In about 90 of these systems, we can pinpoint a problem down to a single part, or at worst a few parts, by comparing the readings of the standard instruments and indicators while in flight. That's what PCI, Pattern of Cockpit Indication, is all about. A new concept of fault isolation. Not that we've forgotten other forms of fault isolation. Many of the aircraft systems can use more than one. Our DC-10 still uses some ground support equipment, GSE. About 25 of the onboard systems can use GSE. Did you realize that maintenance is the largest part of domestic airlines' direct operating cost? That total cost, by the way, was a cool $1 billion in 1968. And 28.5% of that is maintenance. That's even more than the fuel and oil expense. Built-in test equipment, BITE, is another fault isolation method we put in the DC-10. Many of the BITE indicators are in the cockpit and can be used for in-flight fault isolation. Some of them are on the component itself and have to be used on the ground. About a dozen DC-10 systems have BITE. Even with the fault isolation methods that have been available to the airline industry, historic data shows that regardless of the aircraft manufacturer, 54% of autopilot parts removed for replacement were good operating parts. Same figure, 54%, for navigation system parts, 49% for engine instruments. Some other systems run about 1/3 non-faulty parts removed unnecessarily. That's a lot of unnecessary man-hours and unnecessary parts inventory. This problem is solved by PCI, the Douglas-developed in-flight fault isolation system. The new Pattern of Cockpit Indication System, PCI, occupies 1/2 cubic foot and weighs 3 pounds 6 ounces. Only 50% of that is airborne weight. It adds no complexity to the aircraft, requires no connect-disconnect time, and requires no additional training to operate. It is a modular system consisting of 2 units, one airborne, the other ground support. It is available in a model to match every DC-10 aircraft number. It's powered by 0 volts. Well, really, it's powered by months of engineering brainwork and simulator tests. PCI is developed by the engineers who designed the aircraft system, and with the direct participation of airline flight crews and maintenance technicians under ideal thinking conditions. Quite different from the usual conditions for fault isolation. Flight 74 passenger loading has been delayed. Please stand by. No wonder over half the time parts are replaced and the fault is still unrepaired. But PCI works at 97% accuracy. Here's how. The flight engineer's a sharp guy, and during climb-out, he spotted a small problem with our DC-10's avionics compartment ventilation flow. There isn't any. Avionics flow off. Cabin differential pressure above 1 psi. Nope, it's below 1 psi. Here it is. All avionics compartment fan circuit breakers normal. Right. Avionics compartment fan control circuit breaker normal. That doesn't fit. Here's the one that matches, and the fan breakers are normal, and pressure reading is below 1 psi, and the flow is off. No doubt about it, that's it. 21-26F. Seconds after recognition of the problem, PCI fault isolation procedure has pinpointed the culprit. Repair of dispatch critical systems can be arranged by radio. Although this problem is not critical, PCI makes the procedure so convenient that good flight engineer is on his airline's communications frequency now with his flight number, ETA, side number, and the problem code, 21-26F. That code number means a lot to the folks on the ground at the next stop for our DC-10. (21-26F). Better get a fan control relay. No unnecessary parts replacement. We know that's the bad one. If the skilled technician on the ground had received a code with a more complicated repair, like the upper ones on the page, he could have had 2 or 3 parts ready by following the branches. Let's see, this fan control relay has to go up forward. Here. And get in there. Complete detailed schematics are right there also when more subtle problems are encountered. At Douglas, we borrowed regular airline maintenance men so we could run realistic simulator tests, and we got 97% accuracy with pattern of cockpit indication. We're serious about predicting 95% accuracy in airline use. We're serious about cutting 15 to 20% off direct maintenance costs, and that savings amounts to $200 million a year for U.S. domestic airlines. How's that avionics cooling now? Avionics ventilation is beautiful. That's PCI. But you have to get a DC-10 first.